Okay, let's do to this exercise. We have a temporal displacement of mass spring system is described by the following equations. Xt measured in m and s respectively, and the mass is 2 gram. So first, if we have a problem, so let us visualize this problem. All right. Okay, so you have just even though it is simple, so the visualization of the problem will help us to understand it further. Okay, so this is the mass is 0.2 kilograms. So just make it in a standard form, 0.2 kilogram, and it is described by xt. So xt. Okay, so you are given this xt, determine the amplitude, a, omega, frequency, and period. So determine all of them from just this information. Okay, so what we should have here is that we just compare this equation with the x equal to a cos omega t. Okay, from here directly you can get this equal to 2 meter, right? So a equal to 2 meter. So how do we know it's meter? Because it is measured in meter and second. Okay, meter and second. Omega, what is omega? So omega is 2.5 pi. Okay, what is the unit? The unit is radian per second. And what is the frequency? So omega equal to 2 pi f, right? Okay, so by this equivalency, you can get the frequency is 1.25 watt, 1.25 hertz, right? The units. Okay, so 125 hertz. Okay, since you have frequency, we have a period 1 over f, which is 1 over 1.25. You will get about 0.8 second. Now write down the expression for velocity and acceleration. Okay, so you can have this v as a function of time is equal to negative omega a, right? Omega a. So this is 2 sine 2.5, write down again. So you have a full of it is negative 5, right? Negative 5 pi. So let the pi as it is, 2.5 pi t. And then the acceleration as a function of time, if negative 5 pi times it is a square, right? Because omega is squared, times 2 equal to okay, if I'm not mistaken, okay, so this is a cos 255 pi. Okay. All right, so how much you should get? So this is 2.5, right? 2.55, okay, 2.5. So you should get about 12.5 pi square cos 2.5 pi t. Okay, so what is the maximum velocity and maximum acceleration? So this is the maximum velocity and this is maximum acceleration. So Vmax equal to negative, we just take the value. So 5 pi meter per second, and for Mx equal to 2.5 pi as 12.5 meter per second square. So pi, don't forget pi square. Okay, now sketch the value label graph for the complete oscillation. So so we make it fresh again. Okay, so you have a xt equal to 2.5 2.0 cos 255 pi t. Velocity is negative 5 pi sine 2.5 pi t, and then acceleration is negative 12.5 pi square cos 2.5 pi t. Okay, so first let's look for the x versus time and velocity versus time and acceleration versus time. So you have two complete oscillations. So the period you have 0.8, right? So you have 1.6. This is 0.8. Okay, so this is cos. This should be 2, and this is minus 2. So you have a cos. So cos, this is first cycle, and you have another cycle. So sorry, it's the not so good drawing. Okay, so you have this. So for velocity, this is 5 pi, and this is negative 5 pi. So this is first cycle, second cycle. This is sine, right? Sine should be from here because it's negative. Okay, so you have one cycle, and two cycle. Next for A, acceleration, this is 12.5 pi square, so make it clearly, this is not enough for me to write down, but let's look to the shape. This is cos, so cos here and written here, so you have one cycle and two cycle. Okay, so these are the value labeled graph. And lastly, for spring constant, you have omega equal to k over m. So you know omega and m from here. This is 2.5 pi, and k you can get it, and this is 0.2 kilogram. So k should be in some value, so calculate it, and the unit should be Newton per meter. Okay.